This is the CAD CAM tutorial for the S60-133 washer. This one's very similar to other parts that we've programmed. So I'm going to show you actually how to save some time and reuse some of that toolpath so you don't have to program from scratch. Alright, so let's go to Solidworks. Okay, so here we have our washer file running. It's very similar to another part we made. Doesn't use all the same tools, but similar. And if we were to open that part, it's the 111. Okay, this is a tiny part though. Okay, so we're going to make sure we're in CAM, and we need to first set up our job. So we're going to create a job, and we're going to change to mill turn. Our comment is going to be the S60-133 turn complete. Okay, we've got our file already in there. We're going to go from relative size box to a cylinder, and then we need to orientate that cylinder in the same orientation as our component. We're going to pick Z and X axis, select the face of the part, and then we're going to actually rotate it in our screen so that it's like it would be sitting in a lathe as the operator's standing near a controller. Z facing along the axis of our cylinder, and X pointing away from us, and Y pointing straight up. Okay, so our origin is going to be at model front. And now let's go give our stock size. I'm not sure what diameter this is, so let's go to evaluate and use the measure tool to determine what the outside diameter is. And it's 236 thousandths, so we're going to most likely cut this from 1/4 inch material. So we're going to need that number. So if we take 0.25 minus 0.236 gives us 14 thousandths, and if we divide that in half, because we're doing radiuses, our stock needs to be 7 thousandths bigger. So we're going back to our job. On the outside radius, we want 0.007. So our stock's bigger. Front side offset is going to be 0.01. Okay, and then the back side offset, again, we're going to go about 2 inches. Okay, for our 1/4 inch bar, we need a minimum of 2 inches to grab onto. And we're going to say 1.6 of that is in within the chuck itself. We have 400 thousandths plus the size of the part sticking out. We scroll down, our program name is going to be, it's the 133, and it's the first program. So 133.1. Program comment is S60-133 op1 the lathe. Okay, I think we got everything set up there. And then we're going to change the job to be S60-133 op1 for the lathe. That way that's consistent. Okay, now let's save this. And we want some operations. We're going to do a facing operation. We're going to cut the outside diameter. We're going to cut the back. This is really similar to the 107. And we're going to drill a hole. The 107 had a different size hole and it got reamed. We're not going to worry about the reaming for this part, but we can use some of the same toolpath. So let's open that part. And I have all these operations. So the turning face, because I'm starting off with a similar diameter material. And my facing operation, my OD profile, my spot drill cycles are pretty much the same, and so is the parting. So let's highlight all of them. And we're going to say Control C. And then let's go to this part, highlight the operation, and hit Control V. And now we've copied all of the toolpath we generated in the other file. Now, you see all these X's. That means it needs to be regenerated because it needs to be applied to this model. So let's go down the line. We're going to go to the facing operation. We're going to edit that. Okay, and we need to change anything that's different. I don't think there is anything different. We're almost the same diameter. But we're going to go through geometry. Then our sizes. We're going 10 thousandths beyond center line. Okay, let's hit accept. Okay, that's now been regenerated, so the little X goes away on this model. Alright, next step. The turning of the outside. That's the same. Look at the orientation. It's different. We're going to go edit. Okay, and we're going to first start with a tool. Staying the same. Geometry. Now it's going to associate it with this model. Now we're looking at our retracts. We're going to leave all that the same. We're going to leave all of these parameters the same. And we're going to leave all these parameters the same. Let's accept. And we now have a outside pass, leaving enough room for a parting tool. Now we're going to our spotting drill. We're going to edit that one. That's why I said edit. I wanted to edit it. So there's our drill bit. And our inside diameter. Okay, so we want to go half that in depth. So if we go to our calculator again, and if we assume we go to the largest diameter, 0.069, and we divide that by 2, and then we're going to add 0.01 for 10 thousandths. That's going to give us 44 thousandths 5 tenths. Okay, which is going to be the depth we're going to go with this cutter. So I've selected our hole. We're going to this page and we're going to change this value here to our new depth, which is 442 thousandths. Actually 445 thousandths. 445 thousandths. Okay, and that should just leave a slight countersink at the top. Go to our last tab. We're going to leave that at default. Hit accept. So there we've got our first routine for drilling. Okay, now we got a 3/32 drill. We pretty much want the same parameters, but we need a different size drill bit because the 3/32 is too big. So let's change this to the, well, we'll change the description later. Let's edit this operation, and yes, we want to edit it. That's why we picked on it. And we're going to go to the library and we're going to select a different tool. So we go back to the main library that we chose, and we want the cutter that would cut in between 64 and 69, which is a number 9 drill, number 9 position, but it's a 67 thousandths drill bit. So we're going to select that one. It's a number 51 drill. Okay, we got the information edited in there. We're cutting the hole in the center. Go to the next tab. So we're going through our washer, and we're going through by the drill tip, and then we're going to go another 180 thousandths for that cutoff tool to have enough room to cut. So it looks like we're going to actually cut more material than the thickness of our washers to make these. So it's a lot of chips. Okay. And then we go to our last tab and we leave that at default. So let's accept that. and we're going to change this description. Oops. And I'm going to just change it to drill through. Because our setup sheet will say what tool to use. Now the reamer, we're not using it, so we can just delete that one. And then we got our parting operation. So we're going to go edit. It now associates it with the new model. Go to geometry. We're going to leave all this the same, except for we need a new selection point. So remember, we selected the inside diameter, and then it's going to go 10 thousandths deeper than that. The next tab, everything should be at default. Last one's at default, and hit accept. We've now finished programming the -133 op1. Make sure you've saved. Again, you need a post-process when you're all done. You post-process, make sure you have the entire setup that you want post-process highlighted. Post-process, we're doing for the 131 lathe. Make sure it goes in a place you know where it is. We're doing Fanuc turning. Hit post-process. Got our program for the 131. Okay. We can close these apps now. Then you need to do your setup sheet. Okay, same tool list as the other one except for the drill bit that's smaller, and we're not using a reamer. Remember, print this as a PDF and upload that in Canvas. Alright, we're done with that tutorial, and I hope you enjoyed that one being quicker, and we'll move on to the next one.